Today we're continuing with Module 3, Lesson 10, with writing and interpreting inequality statements involving rational numbers. So let's think again. Let's look at some words in the title. Rational numbers. What's a rational number? Let's review what that term means.
It's either a whole number or decimal, but the decimal has to be in repeated order.
Right. All whole numbers are rational numbers. Fractions and decimals are rational numbers if they terminate, which means it ends, like 0.5, or if it's repeating or has a pattern as in the repeating, okay? So those are all examples of rational numbers.
Isn't a rational number a number that can be written as a fraction?
Yep, that's correct. Okay? Now, inequality. Well, if I have to write an equality, what symbol do I use for an equality? What symbol would I use? An equal sign. Now, if something was unequal, okay, where'd my word go? Here. Inequality. So, is my height equal to your height? No. So our heights are unequal. That's an awkward word. So how would we write that? If your height was 5 feet and my height was 6 feet, which they're not, what symbol would I use to show that they're not equal? What symbol could I use?
Greater than, or equal, or less than.
Or I could use 6 is less, whoops. Exactly, I could have a greater than or less than sign. So those are the symbols we use for inequalities, okay?
So there's some kind of sign, and it's like the equal sign, but it has like a line through it.
Yep, that would mean greater than or equal to. And that's something we're going to get into another day. Okay, but for today we're just going to look at inequalities using the greater than or less than sign. So let's take a look at the first example. Now let's pretend I have a pocket in my skirt. And let's pretend that in my pretend pocket I have pretend money. My pretend money is less than $5, but greater than $4. So how much money could be in my pretend pocket? How much could it be? How much? You want to say I have 4? Okay, I could possibly have $4.50. So now we want to see an inequality statement that compares the possibility of $4.50 to the $4. So how could I write that?
Right, the 4 and the 50. Oh wait, no.
Well, I want an inequality statement, so I want to use one of my symbols.
$4 is less than $4.
Right, perfect. That's my inequality statement. That's all you have to do. Yeah.
Is it different if you write 450 then like the other?
No, you can put it the other way around as long as you flip the symbol.
Okay,
All right, now let's write for part C an inequality statement that compares it to the $5. So $4.50 is less than $5. So $4 is less than $4.50, and $4.50 is less than $5. Could I have $4 in my pocket? No. Could I have $5 in my pocket? No. So now we have this written as two separate statements. And to be quite honest, it's a little annoying to have to write it in two separate statements. Wouldn't it be so cool if you kind of combined the two into one long inequality statement? Is there a way that we could do that? Well, instead of having this written twice, why don't we merge them together and just write it once? So that $4 is less than $4.50, which is less than $5. Can I do that? I can totally do that. I can have two inequality symbols in one statement. I can totally do that. If you want to write that statement and that statement below 1C or off to the margin, you can. But we're going to look at that more closely in the next part of your notes. Anyway. Okay, so they want us to graph our answer from the open answer sides on the number line below, and the points 4 and 5. So if we label this as 4, and we label that as 5, it looks like our number line is broken up into tenths. So let's label this 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Remember, we can label our number line however we want. We could have gone 4.25, 4.5, 4.75, and 5. But we've got room so we can spread it out. So we had guessed that it was 4.5. So we're going to plot that on the number line as well. So let's explain in words how the location of the three numbers on the number line supports the inequality statements we wrote in B and C. Well, how can we describe our number line? We could start by saying the numbers go from least to greatest. When I look at it from left to right. Right? That's like how we would read a regular sentence, so a number line too. But we're not done. Let's explain further what those numbers represent. So 4 is less than 4.5. 4.5 is less than 5. That's it. I explained left to right, least to greatest. I explained where the numbers were. You have that whole paragraph written down? Notice it's THAN for comparing, so it's THAN, not THEN. That means sequence first, then. So it's THAN. Okay? So now let's write that inequality statement again using all three numbers. So 4 is less than 4.5, which is less than 5. Okay? So let's practice writing more inequality statements using rational numbers. Take a look at example 1. Write one inequality statement to show the relationship between the following shoe sizes, 10.5, 8, and 9. We're going to start least to greatest. So what's the smallest number there? 8. 8 is less than 9, which is less than 10.5. Now let's write it again from greatest to least. 10.5 is greater than 9, greater than 8. Any questions on this one? No? Nothing? Let's take a look at this table. Weather has been a huge topic lately. We were supposed to get 47,000 feet of snow yesterday. We got an inch. I'm hearing rumblings of more weather this weekend. I am hearing rain though. Snow to rain. I don't know. They never know. They're always changing. I don't know. So let's take a look at this table that's comparing weather, okay? Mary is comparing the rainfall totals for May, June, and July. The data is reflected in the table below. Fill in the blanks below to create inequality statements that compare the changes in total rainfall for each month, which is this column all the way to the right. So first of all, let's look at the table. This is this year's total rainfall, and that's last year's total rainfall. So it looks like in May, negative 1.4. So if we had a negative change in rainfall, did we have less rain this year or more rain this year? This year was negative 1.4 change from last year. So is that negative? And believe it or not, I heard we've already had a lot less snow this year than we did last year. And we're halfway through. We'll see what happens. So, did we have less rain this year or more rain this year according to the chart and the negative change?
We had less rain this year than last year.
Right, we had less rain. That's why it's represented with a negative number. June, did we have more rain this year or less rain?
We had more rain.
More rain, because it's a positive number. We added on to it. And the same for July. We have 0.5 inches more than we did the previous year. So let's order these from least to greatest. Go ahead and do that on your notes. So the smallest number that we have in terms of value is negative 1.4, which is less than 3/10, which is less than 5/10. Now let's order it from greatest to least. 5/10 is the largest number, which is greater than 3/10, which is greater than negative 1.4. Now let's stop and think about it. I know how to order numbers. I know what the bigger number is. I know what the smaller number is. But of those numbers, what's the biggest number? What did we say the biggest number there was? 0.5, which is July. Does that mean July had the biggest change in the amount of rainfall? 0.5 is the biggest number in that column. Does that mean July had the big... Why are you shaking your head at me? You telling me no? Why are you telling me no? July didn't have the biggest change? Which month had the biggest change then? June had the... No, well, that was 3/10. Which month had the biggest change? I'm not saying which month had more rain, which had the biggest change. This had 1.4 change. This had 0.3 change. That had a 0.5 change. Which had the biggest change? May had the biggest change. It was less, that's why it's a negative number. But there was the biggest difference. This was over an inch difference from one year to the next. It was over an inch less, but it still had the biggest difference. So the question they're asking here is, in this case, does the greatest number indicate the greatest change? And we said no. In this situation, the greatest change is in May, since the average total rainfall went down from last year by 1.4 inches. But the greatest number in the inequality statement is 0.5. You need to write that in your notes, please. Pick up your pencil and add that to your notes. So 0.5 is the largest digit, but that doesn't mean it was the biggest change. that make sense? Is anybody still a little confused by that? Okay. Try some more. Try number 5 on your own. Mark's favorite football team lost yards on 2 plays back to back. They lost 3 yards on the first play. They lost 1 yard on the second play. Write an inequality statement using integers to compare the forward progress made on each play. Well, how could we represent the loss of 3 yards? How can we represent that? -3. What about what happened on the second play? Must be the judge they're talking about here.
Hey.
Yes. Well, how would we represent that? -1. But now we have to make that into an inequality statement. So what symbol? -3 is less than -1. Number 6. Sierra had to pay the school for 2 textbooks that she lost. One textbook cost $55 and the other cost $75. Her mother wrote 2 separate checks for each expense. Write 2 integers that represent the change to her mother's checking account balance. Then write an inequality statement that shows the relationship between these 2 numbers. Now I'm noticing on your homework you're not reading the directions carefully and including all parts of the task. This is asking you for 2 separate things. First, write the 2 integers. Second, write the inequality statement. So let's make sure we answer all parts of the question. So when she's writing that check for $55, is that money coming out of her account or going into her account? So how would I represent that $55 check for the textbook as an integer? Right, so here's the first part of my answer as -55. And how would I represent that $75 check as an integer? It's always the same people, and I like that you're all raising your hand, but let's get more people participating. Take a chance, nothing to lose. Right. But now the second part is asking us to write that as an inequality statement.
-55 is greater than -75.
Right. -55 is greater than -75. Because 55 is closer to 0, so that's the larger number.
You did -557.
No, my inequality sign just looks like a 7 because I was writing it sideways. Is that better? I apologize. It was a little sloppy. I could use a different color too if that helps. Better? Okay, sorry about that. Jason ordered the numbers -70, -18, and -18.5 from least to greatest by writing the following statements. -18 is less than -18.5, which is less than -70. Is that a true statement? Explain. And then number 8, you have to write a real-world situation that is represented by the following inequality. -19 is less than 40. Don't forget the second part of the task. Explain the position of the numbers on a number line. So work on those 2 now, and then we'll go over them. All right, let's take a look at number 7. Is that a true statement? No, that's not a true statement. They have the inequality statements reversed. But look at this interesting way to explain what went wrong. You could always look at the opposites. Since 18 is less than 18.5, which is less than 70. Is that a true statement? So the opposites would be in the opposite order. Remember how we talked about opposites on the number line? So that's one way you could explain how it was in the wrong order by looking at the opposites. But basically what happened was they had their inequality symbols in the wrong direction. Or their equality symbols were correct and the numbers were in the wrong order. However you want to look at it.
I said that if you underline 70 is to the left of
Excellent.
and 18.5
I love that. Talk about how it is on a number line. Here is negative 70, negative 18.5, negative 18, and over here would be 0. Since negative 70 is the furthest to the left, that is the smallest number. So we could definitely compare to how they would order on a number line. That's an excellent answer.
Would this be considered correct? No, because if an integer of negative is closer to 0, it's greater, such as negative 18. If it's farther away from 0, then it's less, such as negative.
That's excellent. Very good answer. Now, I'm sure you came up with different examples for number 8, but here's another example. The coldest temperature in January was negative 19 degrees, and the warmest temperature was 40 degrees. Now, here we go. Here's that second part. I explained what my negative 19 was. I explained what my 40 was. I did the first part of the task. The second part is to explain the position on the number line. So this is exactly what Petrus, you did in your answer. And the same with you, Shuv. You explain where they are on the number line. 40 is above 0 on a vertical number line. Negative 19 is below 0. So we know that 40 is greater than 19. This means that 40 degrees is warmer than negative 19 degrees. Think about what it means on that number line. Above 0, below 0, to the left of 0, to the right of 0, to the left of each other, to the right of each other. They don't have to be on opposite sides of 0. Like in number 7, they were all to the left of 0. But it was just a matter of which was closer and which was further away.
I just want to hear my answer for number 7.
Sure.
This is not a true statement. When working with negative numbers, the lower the number, the greater it is. And I just copied,
Well, I don't know if I would say the lower it is. We want to talk about its distance from 0, because lower could mean less than, greater than, below 0, on a vertical number line. So we want to make sure we talk about its distance, or left to right, or top or bottom, because lower and less than could be confusing with each other.
So the lower the distance from 0, the greater.
The further the distance from 0, the less it is. The further to the left of 0 that it is, the smaller that it is, the value. Okay? We are going to work on the next part of the lesson. Talks about the frequency builder. We're going to do that tomorrow as our do now. So we're going to skip this next part of the lesson and just look at our closing. So what can you do before writing an inequality statement involving 3 numbers that would make it easier to write the inequality? So what would be, before we fill in the symbols, what's the first thing that we should do with the digits? If you had to write an inequality statement, what would be easier to do? What did we do with the digits first?
Yep, order.
Right, put the digits in order from least to greatest, then go back in and fill in your inequality symbols. Okay? So if we have the set of numbers, we can write them either way, with the less than or the greater than symbols, as long as they don't specify. If they ask from least to greatest or greatest to least, then you have to be careful which order that you write them in. Now finally, if 2 negative numbers are ordered using the less than symbol, what must be true about their positions on a horizontal number line? What do we know about negative numbers on a horizontal number line? 2 people already answered this before. Who can repeat what they said? If it's a horizontal line, the 2 negative numbers have to be to the left. And which has a smaller value? The one that is furthest from 0 has the smaller value. The one closest to 0 has the greater value. What about on a vertical number line? 2 negative numbers on a vertical number line. Which one has the larger value?
The one closest
to 0. So the one that's on the bottom has the lesser value.